This podcast is brought to you by the School of Advanced Study, University of London.
Well, welcome everybody to the Digital History Seminar. There's an attendance sheet being passed around, and if you could sign that and put your email address in, that would be much appreciated. I'll give you a notice first about the next seminar, which will be on Tuesday the 10th of March, and that's going to be Julia Thomas, Nikki Lloyd and Ian Harvey of Cardiff talking about lost visions, retrieving the visual element of printed books. And they're going to be focusing on the challenges and implications of a big data project that will make searchable online over 1 million book illustrations from the British Library's collections. So that's Tuesday the 10th of March. This whole seminar is going to be live streamed on the blog, and later on it's also going to be uploaded to YouTube, and that includes the question session after the paper, so please don't say anything that you wouldn't be happy to have recorded. Thank you. It just remains for me now to welcome Dr. Jack Grieve, lecturer in forensic linguistics at Aston University, who's going to be talking to us about the analysis of emerging words.
Thank you. Thank you all for coming. I guess I should say first a bit about the funding for this. So we're funded here as part of what's called the Digging Into Data Challenge, which is sort of a data mining for the humanities and the social sciences. It's fun. You have to have a kind of international team of people on it. So our side is made up of me at Aston, along with Andrea Nini, who's the postdoc on the project, and then Yang Sheng Guo and Alice Kasikoff, who are in the Department of Geography at the University of South Carolina. We're funded here by the HRC and the ESRC, and then JISC sort of manages it. And then in the US side, they're funded by the Institute of Museum and Library Services. The project, the bigger project, the idea is that we want to compare dialect patterns to migration patterns. And so we're working on the sort of the dialect side here at Aston, both with US and UK data, although we're just looking at US data today. We haven't actually got the UK data yet. And on the South Carolina side, they're looking at migration patterns based on a big collection of family trees they've downloaded from Ancestry.com. So they've got about 1 million family trees, and that can all be sort of geocoded and then used to track people's migration across the U.S., primarily across the U.S. for that side of the data. And so the idea is to try to eventually take the dialect data, the migration data, and really see how they compare to each other. We're not quite up and running with the family tree stuff yet, but we do have the Twitter data for the US in particular, and so we're starting to do some research on that, or we've been doing some research for the past year on that. And one of the things we've been looking at then is sort of how to track these new words that are coming up in language. It's something that you can only do with all this data, and I'll talk about that a bit throughout this talk. So I kind of want to focus a bit on sort of historical linguistics, just given that this is a historical seminar. There are sort of a lot of different ways people study language change. I guess I'm not a historical linguist myself. I'm a quantitative corpus linguist and a dialectologist, but these are basically sort of 5 general approaches to studying language change or the history of languages. Probably the most sort of well-known one is doing reconstruction. So you have some information about sort of modern language, or some point in time modern language, and you try to then figure out how these languages are related to each other. And so you might try to reconstruct, say, Proto-Germanic by looking at German and English and Dutch and seeing what they have in common. And that's really so focusing kind of on modern language, or at least sort of relatively modern language, and trying to sort of project backwards into prehistory. The next 3 I have listed, they're all more data-driven. So the first one is to basically look at previous linguistic research, or sort of secondary research, in particular looking at dictionary information, right? So there's a lot of studies that are based on the Oxford English Dictionary records. And so they use this information to, in particular, try to track kind of word usage change, often how the meaning of words change. Another approach then would be sort of the analysis of historical text. So you get a big collection of historical texts, and it's basically corpus-based. So the corpus is like a collection of natural language, and then you use this to sort of try to figure out how, often within one language, some features changed over time. That's sort of, I guess, the most sort of intuitive and sort of obvious approach, and what we're going to do today is sort of in that vein, but it's working with modern data and a lot more data. Another kind of interesting approach, this is sort of largely outside of historical linguistics, it's in sociolinguistics, and this is what you call an apparent time study. The idea of an apparent time study is, so a sociolinguist would usually collect data, and they're trying to learn about like language right now, or at least that's sort of on the surface what they're looking at. So they might, say, interview everyone in this room, do an interview with you for a couple hours, record your language data, and then go back and look at some patterns inside of it. Often pronunciation, so phonetics and phonology, because if you only have a couple hours of data, you don't really have enough to do stuff with Lexis. Words aren't common enough to analyze in that kind of data. And then the historical, or the way they then try to analyze language change is they'll then take everyone's ages and they'll use that as a proxy for language change. So you might take some feature and you'll get some from people in their teens, or get some from people in their 20s or 30s, whatever, and then you will chart it and see if you can find a change over time in that way. So that's what we call an apparent time study. It's not really done in historical linguistics, it's more of a separate field in sociolinguistics, but it is another way of looking at language change. There are some issues there, the big one being that you're not necessarily sure sometimes if the patterns you find are change, or if there's something that just everyone goes through as they get older. So you might look at like speech rate, and older people tend to talk slower than younger people. So if you just charted speech rate across all these age groups, it would look like speech is getting faster over time, but it's really just everybody's getting slower individually over time, right? So that's what we call age grading, and that's the bit of the rub with that method. And then, there's other approaches too. I mean, one would be computer simulations, which are being used a lot to, say, study the origins of language and language evolution, sort of going back before we have any data at all. So this is what I'm going to kind of situate our research in, and I'm thinking, I'm going to kind of argue that it's a bit different than any of these. It's probably closest to the corpus-based, it is a corpus-based approach, so we're going to analyze historical texts, but we're not analyzing texts that go back to, the 1600s, we're analyzing texts that go back to last year. So we're on a really small time scale, and that's sort of the approach we're taking. So the big problem you get when you want to try to analyze how words change, as opposed to say how grammar changes and how sounds change, each of those have their own sort of difficulties, but the problem with analyzing lexical change, so change in the vocabulary, is that most words are really rare. So we don't, the problem with like taking any kind of data, like apparent time data, so we do linguistic interviews with each when we gather a couple hours of data, or we get, say, a historical corpus that runs back a few hundred years that we don't have, we don't really have like enough data there to analyze word frequencies and to look at most words. We can look at some really common words, prepositions and articles and stuff, but when it comes to looking at rare words, it becomes really problematic. So there has been a lot of research on lexical change in historical linguistics, based primarily on historical corpora and on dictionary data, but there is a lot of gaps there, and it's primarily a problem with the data. And one of the things we don't know about is how new words emerge in a language. So right when a new word comes up, how does it sort of bubble up, and sort of how does it spread out? So that's what we're going to look at today. Like I said, the main problem here is that words are really rare events. Most words are incredibly rare, and I have a little graphic here to show you in a second. And this means that in order to study rare words, or any kind of, almost all words except the most common, you need really large corpora. So corpora that are much larger than what we mostly work with at this point. And so like I said, that's why most research on lexical variation and change, and not even necessarily change, but just variation, in modern times, let's say, just tends to be based on looking at these really high frequency words. In dialectology, you might do surveys to get some data on less frequent forms, but in general, most historical research has really been limited to looking at these high frequency forms. This is a graphic here to kind of demonstrate what we're talking about. This is working on the corpus that I'm going to introduce in a second. It's a big corpus, so it's a multi-billion word corpus. And what we have here on this graph is, these are the first 100 words in the corpus, the first 100 most frequent words. So the most frequent word in this corpus is I. And you can see it here being about, what would it be, about 45,000 times per million words. Now this isn't usually what's the most frequent word in an English corpus. It's usually this is Twitter data, and so I is really high. But this is the kind of pattern you'll always find. It's called a zip curve, or a word frequency distribution. The basic idea is that you very quickly drop off. So I, is very common, but the next most common word is the, much less common. And quite quickly, this is just the first 100 words in the data set, you're down to, very, very infrequent words. I'm just going to kind of blow up this thing here, so now it's up to 1,000 words. So these are the 100,000 most common words in our corpus, and what we can see is that, you know, all about, except maybe about 100 of them or so, are really very uncommon. And if we take it out here to 67,000 words, you can see that most of these words just don't really occur at all. In particular, out of the 67,000 most common words, and you'll see why I picked 67,000 in a second, most of them occur less than once per 25 million words. So if you have a 25 million word corpus, which, you know, 5 years ago was pretty big, you still can't look at most of these words. And these are just the 67,000 most common words. In our corpus we have about 600,000 or so words. So these words just don't occur, and you need a whole bunch of data to get them. So this is the basic problem you're always running up against if you want to study variation and change in vocabulary. Unless you really want to look at some of these really most common words, it's hard to get the data. So, in particular, right, so all words are pretty rare, or the vast majority of words are pretty rare, but new words are incredibly rare, right? I mean, new words by definition didn't occur at all quite recently, right? So at some point in your corpus, they should occur kind of at zero frequency, right? And so these words are incredibly rare, which means we have to have even larger corpora to analyze new words. And then on top of that, if we want to see how new words change over time, or how they change over space, or how they spread out, and if you want to do both of those at the same time, you don't just need one big corpus, you need one big corpus for every time point, for every region, right? And so you require a whole bunch of data to do this, and this just hasn't been possible until quite recently. It is now possible, though, to start to be able to do this, and that's basically because of all this social media data that's online. The social media data is primarily coming off of smartphones that we're interested in, because in particular we are interested in the spatial dimension of this stuff. And so if you tweet off a smartphone and you have this geocoding option on, then we'll get a very precise longitude and latitude for you. And so from that we can now do a lot of, it's obviously time-stamped as well. I mean, that's all this data is time-stamped, but it's this geocoding that really lets us get to the spatial spread, which is an important part of it. But even if you weren't looking at spatial spread and you just want to look at time spread, you still need, you know, huge amounts of data to do that, and social media makes that available. I don't think there's really any other sources for that much data. At least that's easy to get. So what I want to talk about today then are these 3 points. First, I want to look at how we can identify these newly emerging words. These are newly emerging words basically from 2014. Our corpus runs a bit into 2013. And it's based on this multi-billion word corpus of American tweets. Like I said, we do have the UK data coming, so we should be able to replicate this with UK data, although there's not quite as much, just because there's not as many tweeters. We want to then chart their usage over time, so chart how their usage has changed over time, and try to then find out how do new words spread across time, and sort of if we can find any if we make any generalizations about that. And then we also want to map their geographical diffusion, so see how if a word starts at one location, how does it spread out from there. And in particular, what we're kind of interested in eventually, I mean, we aren't there yet, but trying to find sort of common patterns of how words spread. So those are the 3 things I'm going to tackle today. I'm going to kind of tackle these first 2 together, and then move on to the geographical stuff. So quickly about the corpus. So a corpus is, like I said, just a large collection of natural language data, usually digitized. Makes it a lot easier to analyze them. If you have a billion words, it has to be digitized. You get very far with it. So since 2013, we actually have data running back to January 2013, although we have sort of a split in our data where the format changed. We haven't sort of reconciled those 2 sides yet. So we're just going to look at the sort of end of 2013, beginning all of 2014 data, or most of 2014 data here. The team at the University of South Carolina, who are spatial data miners, have been grabbing pretty much every geocoded tweet from the US and the UK off of Twitter using the Twitter API. And so Twitter, makes an internal API that you can use to get this data, and they encourage you collecting it for research. They make it really fairly easy. I mean, it does take some technical skill, but it's not too challenging. You don't actually have to, say, go onto Twitter and scrape it yourself. They're doing this for you. Basically what we do is we check when a tweet comes off, if it's geocoded, so if it has a longitude and latitude associated with it. If it is, we check if it basically falls within a rectangle that surrounds the United States and the UK. So we're just basically checking every one. If it's roughly in the UK or the US, so if we get stuff that's in Canada and Mexico too, we keep it. Twitter's great for this because, one, there's a load of data there. to it's really quite informal, which is what we want, right? We want the more informal the better. I mean, what we really would like, right, is some kind of spoken corpus here, but we're still not like there, right? We're not going to be able to do that. And you can build spoken corpora, but they're not going to be multi-billion words, right? I don't think it's that long until we are there. But right now, this is sort of probably the best we can get. It's also very popular, right? So there's lots of different people using it. The corpus we have has 7 million different users in it, the one I'm looking at today. So that's a fairly substantial chunk of the American population. It's also youthful, right? So there's a lot of kids on it, teenagers on it, young adults on it, which I think makes it really good for tracking new words, because presumably, although we don't really know this for sure, right? But presumably a lot of new words are starting with younger speakers. It's only based on the geocoded data. That's only about 2% of tweets get geocoded. So if you're tweeting from your computer, it's not geocoded. If you're tweeting from your smartphone and haven't turned on the geocoding option, it's not geocoded. So it's only about 2%, 2 to 3% in the US and the UK that are geocoded. But this still gives us huge amounts of data. I think it's an open question about sort of how representative then is that 2% of the other 98%. And probably, there's some issues there, but I don't think it's a major issue for us. I mean, we're still able to say something about how these new words are spreading based on these geocoded tweets. So what we're going to look at today is almost 9 billion words of data. This is, as far as I can tell, by far the biggest geolinguistic study that's ever been done. One of the biggest linguistic studies that's ever been done. I mean, you do get people working with like the Google Books corpus. That is more data there. But this is a fairly a pretty uniquely large corpus. It's really rich, right? And we have like a lot of data on this, and obviously we have a lot more kind of access to what's going on than we would with Google Books, at least. How I could use it, how you could use it. This is basically every geocoded tweet from the US from October 2013 until November 2014. So it's about 13 months of data. Like I said, we actually have the data running back to January 2013, but there's a switch in our formatting in October, and so we haven't sort of. In fact, if you're interested in the older data, I have a presentation up on my site. You can look at it. It's there. We've done the same sort of study with the older data, but this is with this new data. At some point, we'll be able to kind of reconcile these, but basically, there's some issues with the foreign language data in the 2013 data, and so we get kind of like if you measure the frequency of you'd see a big jump at 2013 because we lose all the foreign language data, so there's not that much of those in the foreign language data, of course, right? It's almost from a billion tweeters, 980 million, sorry, it's almost a billion tweets, 980 million tweets from 7 million distinct users. I mean, some of those users probably have multiple accounts, but there's a huge number of distinct users here. And like I said, everyone is geocoded with the precise longitude and latitude of the user when they post it on their smartphone. We use that information just basically right now to get the county that the tweeter's in. I'll show you how kind of detailed this is. So here's this post. It's actually from the 2013 data. So we get this digital longitude and latitude. It says just posted a photo at the Baha'i House of Worship. So you can see it's sort of near Chicago there. Sorry, we can zoom in on it. We can see it's actually in Evanston. We can keep zooming, and we can see there's the Baha'i House of Worship, and there the person is. I actually think this is probably a little bit off. The person seems to be over here. We actually can take a look at the picture they took, but you can see it's quite close. So it's good enough here to really get people's counties. And we could also go down another level and get, like, say, census tracts. In fact, we're just working on something right now where we're looking at New York City, and we can go in and get every person's census tract. Instead of breaking this down by counties, we can break it down by census tracts. So there's hundreds of census tracts inside of New York City. So we get these really detailed maps, at least in places where there's a lot of tweeters. So this is sort of what the corpus looks like. We have a username for everyone, which we can use to sort of track people back, but we don't publish those, and don't really do much with those either. We have a FIPS code here, so we've taken the longitude and latitude and changed it into a FIPS code. That's basically a numerical code for every county in the U.S. So every county is associated with a unique code. There's about 3,000 or so counties in the U.S. We then have a timestamp, and then we have the message, the tweet, and most of these tweets are highly informal. Like all of these ones are, right? Short, informal. Be tricky to analyze these for grammatical patterns. And it's tricky to do this with most grammatical kind of tools you use for grammatical analysis are sort of work better with, like, say, newspaper data or something really carefully edited with good spelling, which helps you identify different words and stuff. But here, for just lexical stuff or just identifying vocabulary items, this is fine. Okay, just to sort of show you kind of how this works, right? So here is graveyard versus cemetery. So this is South Carolina here. These are the counties. States are a bit darker. So here's North Carolina. Here's Georgia. Okay, and every one of these dots represents a usage of the word graveyard in red, cemetery in blue. And so what we can do is basically tally these up inside of each of these counties, and then figure out what proportion are they using cemetery and graveyard. Here it is sort of aggregated. So you can see on average it's 25%. So on average most people are using the term graveyard, but you can see that we can split it. This is the median value and show that these areas in blue tend to use relatively more cemeteries. Areas in red use relatively more graveyards. Okay, so that's basically what we can do with this data. And it is important that we sort of have some way of binning these points together, and so counties make sense. This way, then we can make a comparison between two forms. And what we're going to be doing today is mostly taking a word like a new word, and we're going to figure out relatively how frequent it is by dividing the frequency of that word out of all the tweets from a particular county by the total number of words in that county. So we can kind of say, like, what percentage of the total words in that county is this particular word we are interested in. But I'll give more information on that in a second. We can also then map this across the entire United States. So here is cemetery, graveyard versus cemetery across the U.S. You can see some kind of clusters here for graveyard versus cemetery. We can also smooth this out if we want. So here's a smooth version of this map. Anyways, this isn't really what we're going to do today, but I just want to sort of show kind of how the data works and how we're working with it. The areas here in white are areas that we don't have occurrences of either cemetery or graveyard. And so you can even see with billions of words, it's not like we have enough for every single county, but this is still a really good resolution. There's nothing really historical about this. This is just sort of synchronic modern dialect study. But this is sort of the other part of the project that we're working on. Okay, so the main point of today's talk then is to try to find these emerging words and then to try to map them across time and across space. So we kind of do this two-step process to find these emerging words. What we first do is try to find words that are showing a big rise in usage. Okay, but these aren't necessarily new words. These might be old words that have just shot up in usage. In fact, arguably some of these new words are kind of old words anyway. But you know, for example, last year a big shooting up word was the word literally, and it shot up because it's now being used to mean figuratively. So you get people saying like it's literally raiding cats and dogs, and so this new usage of literally has really shot it up. And maybe that is a new word. I mean, it is a different meaning of a word, sort of the opposite meaning. But you know, you will get these words that aren't necessarily new. They've just been showing a big rise. And in particular, what you might get is a word that has been rising for the last 3 or 4 years. And so those are probably a bit too late to get those. But it's still the first step. Is we want to take all the words we got and see which ones are rising. So what we did was we extracted the 67,000 words that occurred at least 1,000 times in the corpus. So that's where we got that 67,000 number earlier from. But there's a lot more words that occur less than that. So we extract these 67,000 words that occur at least 1,000 times in the corpus. And for each one of them, we measure their relative frequency per day. So we ignore any kind of geographical information here. We just go day by day, what is their relative frequency? And so what that means, again, is just saying we have, say, 25 million words for this day. Right? Out of all the tweets that have come in on, January 1st, we have 25 million total words there. What we want to know is what percentage of those words are each of these 67,000 words, right? So we see what percentage of the 25 million words from day 1 are what percentage from day 2 are etc. So we do this for every one of our words. And so what we get is this big data matrix with 67,000 words, all measured across, about 13 months worth of days, right? So, a bit more than, let's say, 400 days or something like that. What we then want to do is see if we can find words that are showing a rise over the course of that period, right? So I'll show you some graphs here in a second. And so what we do is we look for a correlation between the relative frequency of the word and the day in the period. So we would correlate. So you have a measurement for day 1, you have a measurement for day 2, day 3, all the way up to, say, day 400, and you see if there's a correlation between the day of the year, or the day of the period, and the relative frequency of the word. This is probably easier to just show graphically. So here is the relative frequency of and across this 13-month period. So down here on the x-axis, this would be, say, sometime October 2013. This is November 2014. Right. So these are the days of the year, of the period. Okay. And then here we have on the y-axis is the relative frequency of the word. So and occurs. This is per billion words. So and's occurring about, what would that be, 13 million times per billion words. Okay, you can kind of see it's, has a pretty steady average. It is showing, it's not just totally randomly distributed here. There is kind of an interesting kind of pattern here of up and down. But it's not like it's showing a clear rise or a clear fall, and hence we get a correlation value here that's pretty close to 0. Okay, so if this was just a straight line showing that we get 0, if it's straight going up, we get a 1, straight going down, we get a -1. This is a non-parametric correlation, so we're not just trying to find a linear pattern up, we're just trying to see if, over time, if things going up or down. So this is and this isn't going to be identified as a rising word because this value is not close to 1. Here's another one, so this is strawberry, and what you get here is sort of a proof of concept, right, is that what you find out is that strawberry is tweeted more often in strawberry season, right, and so this just sort of shows you what you'd expect. So it has this rise, and then it falls down, and this, you know, you can go on to something like Google Trends and type in strawberry, and you'll see this sort of cyclical pattern over and over again. You type in skiing or, you know, summer, you know, any of these things. You type in October, and you'll get a cyclical pattern. Every October will pop up. So this is what's happening here. Now this gets, again, a low correlation, right, because it's not showing a clear rise or fall. Now, of course, if we had a smaller corpus here, and we just say took it from January to May, it would get a rise. It's one reason why you probably want a bit more than a year, right? So even if we took, I don't know, I mean, so Christmas is not a good example here. Let's say we took a, what's it called, Thanksgiving or something. You know, it would have a bit of a fall. So if you take it over a year, then you kind of can guard against these cyclical patterns. But of course, you can just look through the words and sort of figure out which ones are cyclical if you want. Here's another one. So here's this is a bit more complicated. This is word playoffs. So this is American English, and so you get a spike here. This is American football playoffs. This is hockey and basketball playoffs, and this is baseball playoffs, right? And so you just get these patterns. This is what you expect. But what we really want are the ones that are showing a clear rise. So these are the top 10 rising words on Twitter by this metric, okay, from 2014. So these all have very high Spearman correlation values, right? They're pretty close to 1, all over 0.9. Okay, so these all show clear rises. I'll show you them some of the charts in a second. So the number 1 is this word fuckboy, which has been showing a big rise. We have got some criticism. We presented this at the American Dialect Society, and people are saying, well, these are just sort of Twitter words. They're not. I mean, you can really find them all over the web in all sorts of different, you find them in music journalism, and that's where I first saw this word, say, 10 months ago or something. You get in Twitter, though, you do get a lot of these that are kind of Twitter forums or CMC forms, computer media communication forms, especially for Twitter because they're reducing the length of the tweets, right? So you get RN for right now, and this was also the top riser from last year. This has been rising for 2 years in a row. You get happy birthday, and various other ones. And you can see there's a lot of these in here, okay? I think these are still interesting, but they're maybe not quite as interesting as the other ones. I mean, some of these you could just run the actual phrase and see what happens too. Well, you can do that for all of them and just see what happens. But there are some other ones that are interesting in here that we're going to come back to, like Unbothered, and a few others. So these are the top risers for 2014. This is what some of the graphs look like, right? So it really works, right? This method of, you're just basically looking to see, is there a consistent rise in the rank of these relative frequencies of these words over the time period we're looking at. So here's fuckboy, really taking off. You can see, it's not at 0 or anything at the beginning of this. It's not an entirely new word, but it really does shoot up in September 2014 in particular. Here's RN right now. You can see it's actually quite frequent to start with. It's basically you would have just seen if I had last year's data here, it just did this pretty much the same pattern last year. But you can see it does start to look to be leveling off now at the end of this year. We'll see when we get the 2015 data. Here's happy birthday, so another clear rise. Here's fuck with the abbreviation for that FW, clear rise, kind of plateauing off a bit. Here's unbothered, which I'm going to talk about a fair bit in a second. In particular because you can see it's got some hits at 0 at the beginning of this term, so it was a fairly new word. Okay, so through that process we can find rising words. We can find words that are on the rise over the last year, over this sort of 13-month period. These aren't necessarily emerging words though, right? Because a lot of these aren't new words. So right now, the right now one I think is the best example, right? This is occurring quite frequently already. I guess that's 30,000 times per million words. Sorry, 300. Right? So these aren't new words, and this is the problem. We have to kind of filter out. We got all the rising words. For every one of these 67,000 words, we have a value that tells us that they're rising, but we don't know yet if they're new. And I'm not showing you this is maybe the best way of doing it, but this is how we're doing it so far. Right now we're doing to try to find these emerging words and cross-reference this list of rising words against a list of rare words. In particular, words that were rare at the end of 2013. So words that were very uncommon at right before the 2014 started, and then that showed a big rise. Okay, so this is one way of trying to get to these sort of emerging words. we can maybe do something a bit more complicated here and maybe get a bit more back, but this does seem to work basically. I like to visualize this too. So what we have here is this sort of similar to the last graph, to the zip curve graph we showed. So over here we have the relative frequency of these words in the fourth quarter of 2013. So their average relative frequency in October, November, December of 2013. You can see here's I at the top again. Here's 2 and the U. Okay, so basically that same pattern we saw before. But instead here of having the words ranked, like we did in that last graph, we have them with this correlation value. So words over here in green have been showing a fall over the last year. Words over here in blue, on the far right side, are showing a rise in 2013. Okay, words that are 0 are basically showing something pretty flat, like here's and, which we looked at, right? So it's right in the middle. Okay, so one thing we can see here is something kind of interesting, that even though I is the most common word in Twitter by a long shot, it's much higher on the y-axis there. It's also pretty far over to the left, meaning that it's becoming less common over the year in Twitter. So I is falling over the course of the year. So are some other related words like me and my, it, another pronoun there too. You also get used sort of on the downfall a little bit. You get some verbs as well, like contracted am and the word be. On the other side, words that are rising are words like the, and then also so articles, but then also all these prepositions like from, in, of, on. There's a couple others in there. But anyway, so a lot of these prepositions. And I do think what we see here is, I mean, it's not the point of today's talk, but there is a sort of style change in Twitter. And what kind of at least some linguists would be able to spot here is that a lot of these words are associated with more kind of informal language. So lots of pronouns, lots of verbs is an informal feature of language. If you took a look at conversation, it tends to be really high with verbs and pronoun usage. If you take a look at like academic writing or newspaper writing, it tends to be really high with prepositions and article usage. The reason why is because academic writing and newspaper writing tends to be really dense, so they have really complicated noun phrases in particular. That's how we pack lots of information into academic writing and into newspaper writing. It takes some time to do that. You have to be able to edit your writing to be able to really do that. If you're talking quickly on the fly, it's a lot harder to pack really complicated noun phrases, and you tend to then use more pronouns and verbs. And so what this looks like overall is that tweets are becoming a bit more formal over time. My guess is it probably has a lot to do with, say, people like us tweeting. So I mean, more and more kind of sort of academics and older people, etc., taking up tweets, and then our tweets are naturally a bit more formal, whereas kids' tweets tend to be much less formal. I think they're probably the earlier adopters of this. Anyways, the point really though is that what we're interested in are these words right down here in this bottom right-hand corner, right? These are words that are very rare that are showing big increases, okay? So this is 67,000 words, and so of course, you only see about 40 up here at the top, so most of these 67,000 words are incredibly uncommon, right? So what we can do then is start to kind of zoom in. So I'm going to sort of blow up this y-axis and just sort of zoom in here to like the top, I don't know how to show you. Okay, so here we go, we're kind of zooming in and we're seeing sort of this big cloud of words at the bottom. This is where most of English words are, right? Most English words are very uncommon, like we already said. You'll see it kind of peaks here in the middle, so most aren't really rising or falling. But again, what we're really interested in is just this bottom right-hand corner here. So there's right now, for example, popping up there. You see them more clearly here. Here's right now, here's because. Okay, a bunch of these sort of abbreviated forms. Over here you have some interesting ones, like one thing that's really been falling over the last year in Twitter are all of these laughing words. So ha ha ha, LOL, all these are on the, there's another ha ha ha. Okay, I mean, in fact, if you take a look at the top 10 falling words, they're almost all ha ha ha, or variants of he, ha ha, or different spellings of that. So we can keep zooming in here, right? And you can see there's just a massive amount of words, which are all very uncommon, right? I mean, now occurring, the majority is less than 30,000 times per billion words, which is very infrequent, right? Given that, say, like most corpora are, a big corpus is 100 million words, right? Like the British National Corpus, which is probably the gold standard, is 100 million words. So there's not a lot of data there to look at most of these words, which is the point I was making earlier. And so we can just keep zooming in, and we can now start shifting over here to the words that are rising, right? So these words in green are falling, and obviously there's not too many words at this little spot, because these are falling words that are also infrequent. You can't really do both of them. But what we're really interested in is just this little corner here, so we can kind of just zoom in on them. Okay, and these are the very kind of edge of language, right? These are words that are incredibly uncommon, but have showed huge rises over the last year. And so these are the kind of words that we're interested in. These are just sort of, you see this sort of big cloud, this lexical cloud of language. These are things that are right on the edge of it. Just they're sort of popping up on the edge of language. A lot of these words are proper nouns, right? Or people's names. Those two things are pretty common. Like here's this one here, Anderson. This is just the name of some small clothing company that just really started tweeting a lot over the course of the year. And it just, just over this time period happened to be really advertising their company a lot, and there it popped up. So we're not really interested in these particularly. We'll also get some ones in here that are like apps, for example. We're not interested in those. And depending again on how you take this, you get different stuff. But we are interested in some of these words are things that are, genuine words or genuine phrases. Some of them like this one here, get me fucked up, GMFU. And these are the ones that we're interested in. These are emerging words in English over the last year. So here then are the top 10 emerging words on Twitter. These are basically words with the highest correlation there over time, and that I think that have a frequency of under 500. I think is where we're going to cut off. Well, if there's fuckboys, which makes it so somewhere right around there. I think 500. I mean, that's sort of an arbitrary split. You could fool around with it a bit, but these would always be in there. These are at the top of that list, no matter what. So the number one is Unbothered, which we saw earlier. That was also one of the top risers. GMFU was also the top risers. These other ones weren't. I mean, we have the plural form of fuckboy. That is still there. But fuckboy, the singular form was a little bit too common, so it just got cut off here. But, basically, these are your top words. I'm going to talk about each of these in a little bit of detail, but these are the kind of main risers. So we get Unbothered, which, basically means not bothered, and it's not even a particularly new word. I have a graph in a second I'll show you, but it seems to mean something a little bit different than just not bothered. It means something like kind of happily oblivious or something like that, or purposely oblivious. We have this GMFU abbreviation, but you'll see there's less abbreviations here in particular. We have joggers for jogging pants or sweatpants. We have the plural of a fuckboy. We have wrecked, which is this spelling of the word wrecked, but it means sort of as in drunk, basically. Or at least that's sort of the general, the more common meaning of it. This TFW is one, we haven't actually looked at that field when, and you notice what we haven't done here is run sequences of 2 words, right? All we have here are individual words, right? Things that are split on either side by a space, basically. So you can think there's a whole bunch of phrases we could be running too, but this then becomes very computationally tricky, right? I mean, as we take every pair of words, it really blows up the amount of computation we have to do. We have things like Xans for Xanax. I mean, this is sort of a proper noun, but I don't think it is. I mean, this isn't meaning exactly Xanax, as in it has to be Xanax, just some kind of benzodiazepine pill. Bayless, so bay was a big word the year before, and it means sort of your significant other, basically. So that's now a bit too common to make our list. That actually made our list last year, but bayless, this form, so to be without a significant other, be single, basically, is there. Boolin, this is one, a lot of these are kind of maybe a bit less interesting because there's things that we kind of figure out already, but Boolin's a good one because it's one you probably couldn't figure out on its own. It means basically to hang out, especially with a group of young men hanging out. So it comes from cooling and boys cooling together makes Boolin. Lort as an exclamation, that spelling, and that's sort of that pronunciation. Selfie as an alternative spelling of selfie. Slays, which I was surprised by because to me, I've sort of known this meaning of slays. It's often used in he slayed that guitar solo is by far the most common way that slays gets used. But that really shot up in the last year. Famo for family and friends, some of this alternative spelling for fuckboy. One that's made a lot of news over the last year is this on fleek, which means on point. It's usually referring to eyebrows, so like very well plucked eyebrows are on fleek. To fave something. This gains one I like, it means your earnings, basically. Brew for bro, I'm not sure if I pronounced that right. Am I right? This sort of contracted form of am I right? This one also showed a big jump up really quite late in the year, notice for notifications online. So you see we get quite a bunch of different types of words here. I mean, they all tend to be highly informal. I mean, it's not like we're getting new scientific terms or new, I don't know, new technical terms. These tend to be kind of split between sort of full language and then sort of Twitter acronyms, and those tend to be what we're getting. But I do think, especially some of these, these words like fuckboy and unbothered and bayless and boolin and stuff. These are real words that are just kind of emerging right now, and this is what the methods let us do. Here's what some of these graphs look like for these. So you'll see they all show clear rises. So here's unbothered. What I did want to point out with unbothered is that we can back this up to some extent by, say, looking at like Google Trends. So this is looking at search hits, and you can see that unbothered shows this real big rise starting in 2013. Sort of right here it is at sort of near the mid-end of 2013, and so we get the same pattern here, right? But that said, unbothered, like I said before, this is off of the Google Books corpus. This is a huge corpus of books, and you can see it's actually first attested there around 1860, 1870. So it's been showing this rise for the last 100 years or so. But it's really jumped up now in the last year, and I do think it's jumped up with a different meaning, and that's this meaning of being sort of happily oblivious to things going on around you. Here's GMFU, here's joggers, so this has a kind of interesting one, this sort of double peak. Here's fuckboys, it's a lot like fuckboy, if you look at the other one, but you just see it just has a few more zero hits here. Here's wrecked, you see this one we really caught early, right? So it's a lot of zeros down here, maybe we kind of caught this one at the right moment. Here's that feel when. This is a nice one, it's that feel when has actually been used more and more. It's this phrase that means something like, well, what's the example I just saw the other day was, that feel when you get home from work and take off your shoes. Or that feel when, it's just this sort of way of sort of kind of identifying this moment in time as being sort of an interesting thing. Here's Zams, here's Baelish, you can see this one sort of had a sharp jump and then really quickly kind of leveled off. Here's Boolin, here's Lord. One point I want to make here quickly is that these follow what you might call an S-shaped curve. So at least a lot of them look like they're either starting off, so they have a sort of big jump. We haven't actually seen them plateau yet, but some of them do. So here's right now. I mean, these are both rising and emerging words, right? So it sort of starts off slow. I mean, this could go back in time a little bit too, right? And then levels off. Or here's Baelish, right, which shows it probably most clearly, where it's just sort of going on really infrequently. It jumps up and then it levels off. This is something we might expect to find. So in sociolinguistic apparent time studies, these studies where they look at people's ages as a proxy for time, they always find these kind of patterns. Historical linguistic research finds these kind of patterns. Also, similar patterns have been found in all sorts of research on the diffusion of innovation. So diffusion of farming techniques, diffusion of some new idea coming to a community, often is a term for it, it's called the S-shaped curve of diffusion. So this is something that I don't think anyone's ever really noticed with lexical stuff, although if you just look at Google Books, I guess you probably could to some extent. But this really shows that these patterns that we're finding aren't totally unexpected. I mean, I think they're kind of what you'd expect, right? Something kind of goes along slowly, and then at some point people pick it up, and then at some point it levels off, right? A lot of words don't ever jump up, right? They just sort of stay down low and then die. Here, for example, is sort of an escape. Sort of to show the point. This is from a linguistic study. Here's one from a diffusion study. So sort of similar kind of patterns. Okay, so just to summarize then, with the time patterns, what we show then, right, is that new words rise and fall really quickly in modern English, right, with numerous new words entering the language and also falling off the language every year. And this is why we need a lot of data, right, and why we need like short data, right, data that becomes really dense, because these words are not things that happen over 100 years. These are things that happen on like a month-to-month basis. And the only way to get that kind of data and to analyze these words, like realistically, to see how new words come and go in the language, is you have to have really dense amount of language from a short period of time. Obviously it'd be great to have this much data for every year back to 1800 or 1500 or something, but at least we can do this currently with modern words. The other thing we found at one point was just this S-shaped curve, which I think is interesting and sort of shows that these words are sort of behaving how one might expect if you say do research on diffusion or even in historical linguistics. Okay, so the second part of my talk then is to talk about the geographical diffusion of these words and to map their spread. So as I said, we have all this geographical information, right? Because all these tweets have been geocoded, and so this lets us do. And this is, I think, probably what's most innovative here, because you could kind of do this. I'm not sure anyone really has, but you could do this kind of this first step, looking at say Google Books, and get kind of a similar result. But what you can't do with any data set is, except this one. I mean, there's some smaller ones that are sort of building up from Twitter as well, but it's really look at this geographical pattern. So this is more both my interest and as a dialectologist and also my colleagues' interest as geographers, right? And so this is really taking advantage of this really rich data that's coming off Twitter. So a technical problem we have to deal with, right, is how to map the spread of a new word across the region. And the most obvious way of doing this, I guess, is to have a time series. So have a bunch of maps that, a sequence of points in time where you map across an entire region how frequent the word is. So basically what we do is for each county, we say, okay, so at this point in time, how much data do you have for this county? And then how frequent are each of these words? So you take unbothered and you say, okay, so in this county, on the 1st of January, what's its relative frequency inside this county? And then do it on the 1st of February, and then keep going, right? And so this is what these look like. So here it is, unbothered on the 1st of November 2013. You see it doesn't have much of a spread, okay? we obviously didn't catch this word right at the beginning, and I don't think we ever really can on Twitter, because these words, I mean, maybe with some of these abbreviations, maybe they do start on Twitter, but these ones don't start on Twitter, right? So I don't think we're going to really get right down to the core moment they started, but we can get them still pretty early now, right? And that's the thing about Twitter, is there's a lot of people on there and tweeting tweeting regularly, and so we do get these pretty early on. Okay, so we see this sort of pattern. I mean, it's basically kind of spread out. We don't see it in the north much. These are mostly in big cities. There's Washington, D.C., there's Columbia, there's Atlanta, there's Houston, there's Los Angeles, there's Las Vegas, there's Miami. Okay, so these are mainly in big cities, but you can see it is sort of concentrated here in the southeast to some extent. Okay, so what we're going to do then is run through this. This is cumulative, so it isn't. So this is everything up to the. This is everything up to the 1st of November. This is everything up to the 1st of December. Okay, so we just kind of build this up, because then we're getting more and more data with each step. Okay, so we can just sort of run through it. You see it sort of spreading out here in the southeast. Okay, you see it spreading out elsewhere as well, but in particular in the southeast. Okay, and you see it sort of over time. Now this is the March 1st. It's getting more spread out as we go on. Here's June. Okay, you can see quite a big jump here. This is where that curve starts really moving quickly. Okay, here's July, August, September, October, November. Okay, so at this point now, we see it's attested across a lot of the counties, but probably still a minority of counties. This is about 3,000 counties in the U.S., but we can see it's really quite dense here in the southeast. Okay, so that's our attempt there to kind of map the spread of this word. Just to run through it again. See, it sort of spreads out here, mainly in the southeast, but then up to these other cities as well. One thing we can start to do with this, and we're just starting to do this, is start to kind of use this data to try to assess these different theories of how linguistic forms spread. So although there hasn't been a lot of work on lexical spread, there has been a fair bit of work on phonetics, how a speech sound spreads, how grammatical construction spreads, because those are more frequent, so we can look at that in historical data, we can look at that with interview data. And there's two main theories in linguistics, and I suppose probably in other fields as well. I don't think these are unique to linguistics. One is the wave model, and that says that a word starts here and it just spreads out from that location outwards, right? So it just sort of radially spreads out from one location, or maybe multiple locations, but it's going to spread out just basically on space. The gravity model is sort of the alternative. That says that distance matters, but what also matters is population size. So it's going to jump from one urban center to the next closest urban center, and do that, and then gradually fill in the more rural areas in between based on population size. Okay. And so what I would like to do then is sort of try to assess this by, I think it's a bit hard with that huge map, because there's so many different things going on, and obviously we obviously didn't get it right at the very beginning, and like I said, I don't think we really will with Twitter, unless it's really a Twitter term, but we can zoom in, say, on one state, where we know it becomes pretty common, like Georgia in the south, and then see if we can kind of assess whether the wave or gravity model matches better. So here's the population density of Georgia, right? And so if you expect it to follow a gravity model, you expect it to be, say, jumping from Atlanta to Augusta, Macon, and Columbus, then to Savannah, or maybe from Atlanta to Savannah. That's the second biggest city in Georgia, but something like this, right? You expect it to hit these cities before it fills in the internal area. If you think it's a wave model and it starts in Atlanta, it's just going to basically, go out and it'll hit the south last. Okay, so I'm just going to run these beside each other. So on the right we have the population density. On the left we have the same maps we were looking at before. So this is just the relative frequency of bothered in each of these regions. So what you can see here, right, is that we have it starting off here in Atlanta, which is basically where you expect, is a big city. But this one here is not a big city. Okay, this is a county, I can't quite remember now what it's called. It have a very high percentage of African Americans. I'm going to come back to that in a second. Okay, here's the next point. You can see it has jumped to Savannah, the second biggest city in Atlanta. So in Georgia, that's sort of what you expect by the gravity model, and it's also spreading out from Atlanta. Although this is all pretty urban areas, so I'm not sure this is sort of both what the wave model and the gravity model would predict. Still, this is not predicted, right, by a gravity model. What we then start seeing is here's another one that pops up, right? This is not a big city. It shouldn't be the first one, right? This should take some time to fill in here. I mean, it is more dense than the surrounding counties, but it's not more dense than, say, Macon or Augusta or Columbus. You'd think it would hit there first. This is, again, a place that has a very big African-American population, though. And then it sort of keeps spreading out here from Atlanta, starts spreading out from these other starting points, right? Okay, it takes a while, though, for us to really get to Macon and Augusta, these next two big cities in Columbus. That happens in basically around June, which is where that really takes off, where you really saw it kind of spread across all the United States quickly. Okay, here it keeps going. Okay, and we get to November, this is what it looks like. You can see this doesn't really match either theory, really. It's not like it's just spread out radially from Atlanta. It's also not like it's just hit all the big cities in order. It looks like it's doing a bit of both, really. It did jump to Savannah quite quickly, so we do see something that you would predict with the gravity model. At the same time, it did sort of spread out radially from Atlanta and from some of these other early adopters. It sort of spread out from there into the rural areas. Say this county right down right here. So I think what we see then is more complicated than either the wave or the gravity model would predict. It's sort of some kind of interaction between the two, but there's also some other stuff going on there as well. I mean, I think that's sort of what you'd guess if you were kind of agnostic about just going in, is that both of those theories would be too simple, and they probably both have some truth to them, but there's something else going on there too. In particular, what's really, I think, going on here is African American. This is an African American term, it looks like. That's why, part of the reason why it's really spreading in the South is where most African Americans live. Here's a map of where African Americans are in Georgia, and so you see up in the north, and this is the truth across the South, is up in sort of in the upper South you have fewer African Americans, and this is what kind of part of what's called the Black Belt of the U.S. And so you can see that we have there's these counties right here that were early adopters with really high African American populations, and so if we put these beside each other. Here's the population density pattern. Okay, you can kind of see some similarities, but then here's the African American one. You can kind of see that this sort of African American arc here, and basically is picked up there too. So there's obviously at least three things here that are predicting. One is population density, one is space, and one is African American population too. So there's sort of a demographic predictor in there as well. Something we'd like to explore in the future, right? Is how to model all these things at the same time. And sort of, what you'd like to do is you say, oh, here's a word starting in Georgia. We know what the curve looks like. So now, given those two information, let's model what we'd expect it to look like under the gravity model, what we'd expect it to look like under the wave model. We can actually do a comparison of the two and see which model does a better job of predicting reality, and then also try to work in race and try to see kind of what's the best model we can come up with. Great. Okay, the other problem we have though is that, it's nice to do those animations, right? But it's quite a bit of data to look at, and it's not the most efficient way of presenting that data. So the other thing we were kind of interested in is on how to, and obviously we can't really do that in a journal, for example. It's hard to do that with a lot of words. So one thing we like to do is how to map spread on one map. So, we want to show this time dimension, but without showing a series of maps, how's the best way of doing that? So there's a few different possibilities. The one is just to look at relative frequency. So just to take that last map, the last map of our series, and just sort of show it. And that does show you something about spread. You can kind of say, okay, this is spread out in the southeast. You can sort of see that there's some hot spots here in sort of like big cities like Atlanta, New Orleans, etc. But this doesn't take any kind of time information into account there, right? There's no historical information in there. So there are some other approaches. This map here shows the month of first appearance. Okay, so in red you have counties where Unbothered showed up in the fourth quarter of 2013. In orange you have ones that showed up in the early part of 2014, in yellow in the mid part of 2014, in green in the late part of 2014. And so this does have some time information in there, right? In particular, you can see, for example, there's Atlanta in red, right? There's some problems with this map, and the problem with this map is that there's a different amount of data in each one of these counties. So cities in particular will have a lot more tweets. So we have a much better chance for Unbothered or any other word to pop up there, right? And so it's a bit, this is all kind of biased then by the amount of data we have for each county, which is basically highly correlated to the population density of each of these counties, right? Or actually just not really population density, but just the total population of each of these counties. So this is okay. It is kind of a nice graphic, and it does show you something, but it's a bit problematic because we have different amount of data in each of these sample locations. So another way of doing this then is to count the number of words until the first occurrence. Okay, so this way we can say, there's a lot of data in one of these counties. That's fine. We just say how many words do we have to see until we saw that first word. And so this is that map. But you see these maps are all looking kind of the same, right? So this just tells you, this is, 11 words was the fewest number of words for any county before we saw the word Unbothered, and the most was something like you see 11 times 1,000, so 11,000 words. The most is, up in the millions of words before we see it. Again, you kind of see the same pattern here, but the problem here is that, this isn't very robust. You just get one occurrence of Unbothered, it's sort of a bit random, right? So we can kind of get this a bit better then by looking at how long it takes to get the second occurrence. And when we do this, it kind of filters out some of this noise. Like in particular, up here in North Dakota, like if this is an African American form, you don't really expect to see it a lot in North Dakota, right? There's probably no place there's fewer African Americans. But there's also very few people here. So someone happened to use unbothered pretty quickly, and like we saw, unbothered is not a totally new word. And so if we start looking at the second word, we filter that out, and we can start to see it really, being focused here in the southeast. And if we look at the third occurrence or the fifth occurrence, we can really start to see this. And so I think this one here is probably a pretty good way of showing this on one map. And if we want to start doing some multivariate analysis, which is what we want to do, so we'll take like these maps for a whole bunch of these new words, we can start trying to find common patterns of spread. We're not quite there yet, but this is the kind of map I think we'll probably end up using. We can look at these maps for these ones as well in this way. So here's the, so unbothered map is this one here, right? So it does show this sort of southeastern pattern. It really shows, it really looks like a kind of a South Carolina form, Atlanta, sort of throughout the sort of Black Belt region of the United States. We can also go in and look at the users who are first using these terms, and about 70% of the first 50 or so users of unbothered are African American women, and so that also sort of supports that. Let's look at some of these other ones. So here's Get Me Fucked Up, and you can see this one has a different form. Like this is more, right, this is the fifth occurrence, so this is this sort of filtered out version. You see it's more of a California term, and it kind of has this interesting kind of pattern along the sort of southwest, and up in Seattle, the Bay Area, this is I think Fresno or something like that, or Bakersfield, and then also down in New Orleans, and sort of spreading out through the southwest. Here is joggers, and this one here, even at the fifth word, doesn't really show much pattern. It seems like this is sort of popping up everywhere. I'm not sure why. I mean, it's sort of a, jogging pants exists as a form, and maybe joggers is a bit more is a bit more common. There's also this potential problem here with the term joggers being used as in for runners. It's various small percentages of the data points. I mean, most joggers, we've gone through kind of 100 or 200 of these, and they're mostly kind of 95% is using it for meaning the pants. Here's fuckboys, and so this one gets us quite a different pattern, right? So it's largely absent from the southeast, and it's a New York form, and they sort of spread across the north of the country. Here's wrecked, so more of a west coast form. Here's that feel when, more of a west coast form. Here's Zans. Again, this one here shows more of a widespread pattern. I think that's probably because it's sort of an obvious abbreviation of Xanax, right? I mean, there's just less creative, and therefore maybe it has multiple starting points. Maybe. I mean, we maybe don't have quite enough data for this. Here's Bayless, a bit more of a southeastern pattern. This one is spread out a bit more too, but that's probably because Bay is already spread. Bay was a southeastern form. Here's Bulin, so you can see it's really concentrated in Georgia and this sort of South Atlantic region, but also spreads out. This largely maps up against an African American population. Here's Lort, again a southeastern form. I think if we look through these, what we see is sort of two main patterns. We have the southeastern forms, which tend to be initiated by young black people, especially young black women, and then we have these sort of more northern forms. This one's probably the best example, which appear to be often introduced by young white men. Here's some others. We don't kind of go through them all in detail, but that's what they look like. You can put those in more detail. There's like some nice ones in here, like Gaines, which really shows this sort of southwestern California pattern. Okay, so just to wrap up the regional patterns, I think what we want to, we don't have quite enough data yet, and this is really kind of showing the limits. Like even with billions of words, we still need more data to really find these common patterns and to really catch these early enough. But we do see that they're starting off in the southeast and the north and the west, and then they tend to spread within these regions first. And these largely correspond to modern American dialect regions, and so it seems like words start within these regions and sort of show similar patterns if we looked at it, not historically, but synchronically. And also, the spread of words is really complicated. I mean, it looks like it's affected by proximity, like the wave model predicts, also by population density, like the gravity model predicts, like I said, also by demographics, also by sort of dialect regions, which are presumably largely related to, say, cultural patterns, okay? So, it's a really complicated topic, and we still don't have enough data here even to really dig our teeth into it yet. I just want to then wrap up with just talking about sort of going back to this question of how to do historical linguistics. Like I said, most research and most empirical, data-driven research in historical linguistics on language change is based either on these historical corpora, which, the Google Books goes back to 1800. We're not talking ones that go back maybe 1500s, right? That's sort of the main source. If you're going to do within a language like English, that's sort of the main source of data. The other one is to do these linguistic interviews, right, and to do apparent time studies. But then we're still talking about generations, right? Because we're talking, we get everyone in, you get a bunch of people, you got maybe 100 years or 80 years represented there. So both of these sources of data tend to provide pretty broad temporal scope, right? We're talking about at least kind of 100 years, maybe 500 years. But on the other hand, they have very limited temporal resolution. They don't have much, they have 500 years of data, but it's not like they got it day by day, right? And they also very limited amounts of data. They don't have very much data for any of these points. And so there's a bit of a trade-off there. You get this kind of really broad picture, but you're very limited on what you can look at. And in particular when it comes to words, it's not a lot you can really look at carefully. And so this is something I just sort of came across the other day, I guess even from geology, the uniformitarian principle. And that is that, that probably one of the best ways of understanding the past is to look at ongoing processes right now and look at them in detail, because we're here and can see them happening and we can study them in more detail. And I brought it up because I was just reading Labov, who's sort of the main figure in sociolinguistics and really done a lot of work with apparent time studies to try to find historical patterns. And he cites this as a reason to look at apparent time data in place of historical data. Historical data has much broader scope than apparent time data. We're talking like 500-600 years, let's say, whereas apparent time is maybe 2-3 generations, so let's say 60-80 years. But the same kind of argument applies to say, let's look at really modern data and just look at contemporary corpora, where we have precise time information, it's just over a very short period of time, and use that to try to figure out what's going on historically. It's obviously not like the whole picture, but it's a different approach to it, and a different perspective, which I think is really valuable, right? That you can, if you want to learn if you want to see how new words emerge, and you think that's important to the history of language, I think we'd all agree it is probably. You almost have to then look at really modern data, take advantage of all this big data, and really get into the details and really go into detail for kind of short periods of time. So that's sort of what I want to conclude with, is just that I think that with these new sources of sort of modern data, mined from online sources, especially from social media, which allows us to get these really unprecedentedly large, rich, and dense natural language corpora, that this is really kind of a new approach, a modern approach to historical linguistics, which will, doesn't let us answer all the questions, but lets us have a new perspective on things that we couldn't hope to look at before, and kind of have a more kind of comprehensive view of language change, especially in the lexicon, although, I think grammatical in particular we can do a lot of work with here too. So although we lose a lot of historical scope, we do get a lot more detail, and I think that's really, really useful, and we can look at things like how new words emerge, which is something we couldn't really properly do 5 years ago, let's say. Thank you.
Thank you very much indeed.
Thank you.